The Rock Whisperer. Do you hear the earth talking to you?
Seven 4 factors that affect the rate of weathering. So there are three main factors that affect how quickly rocks are going to weather. And those three different factors are climate, mineral composition, and our surface area. So just giving you that little bit of introduction, what I want you to do in a second is to pause the video. And then I want you to define quickly what climate is, really briefly, just a couple of words. There doesn't need to be complete sentences. And how is that going to affect the weathering of rocks? Think back to video 7.2 and 7.3 on the mechanical and chemical weathering. How will the mineral composition affect the rate at which rocks are going to weather? Define how the surface area, how much space the rocks take up, is going to affect weathering. And we haven't talked about it, but I want you to see if you can come up with what you think a definition for the word stable rock would be. So at this point, pause the video, do those definitions. After you do that, come back to the unpause and we'll go through the rest of the video. So hopefully you've got some good answers, and let's see how correct your answers may be. And again, if you have something that you think was correct and you're not quite sure, feel free to ask a question in class. So, climate regions. Climate is temperature, how hot or cold, and humidity, how wet or dry a particular type of climate is. Climates that are hot and dry, like a desert, are not going to be likely to have any frost action or that mechanical type of weathering. Why? Because we're not going to have those extreme temperatures and we have no water for that to happen. Because it's very hot in the desert and really cold at night, you may have the exfoliation that's occurring. The rocks are going to expand and contract at a great rate, and therefore you may have rocks break off like that. On the other hand, if you have a more humid climate like this picture and there's lots of water, you're more likely to have a lot more acid formation in that particular area because of the water dissolving those minerals, and that will help break down the rocks. The next one is the mineral composition. As we learned earlier this year, and I believe it was Unit 2, we talked about rocks and minerals. So each mineral, and I showed, here's a picture of the Mohs hardness scale as a little review, going from talc, which is very soft that you can scratch with your fingernail, up to diamond, hardest known substance to man. Those are going to affect how well, or how fast, I should say, a rock is actually going to weather. So the softer a mineral is, the more likely it is to erode or break down, whether it's being hit by other particles or whether it's an acid eating away at it. Granite is a great example. Rocks that are made out of granite usually are pretty strong and don't weather a lot. Why? Because they're made up of a lot of quartz. They may also be made up of feldspars, which are in the same area here, so they don't weather as quickly as some other rocks. And the last is surface area. And we'll go over this a little bit more in class. I have a good example I can show you in class too. But if we look at this initial square here on the left-hand side, and we measure it, and it's 2 units by 2 units. 2 times 2 is 4. We're trying to figure out the total outside area of the square. There are 6 sides to a square, and it's 1 cube. That gives us a total surface area of 24 units. But if we break that rock apart, and now we have 8 squares, well, 1 square is 1 unit by 1 unit. But that has 6 sides, so that's 6. And then there's 8 of those squares. Our surface area just doubled to 48 square units. And if we break each of those even further into further smaller squares, and each of those are only a half a unit on each side, we get 0.25. That has 6 sides. Then we multiply that. Now we have 64 squares though. So even though each little square is smaller, and that because we have so many of them, we're increasing. We're getting all those inside surface areas. So rocks that have a larger surface area, more smaller pieces possibly, are going to dissolve or break down a lot easier than a large rock. So a stable rock probably is going to be relatively large, and because it's stable, it means it's not going to break down. Like I mentioned before, granite is a good example of a stable rock.
Don't forget to listen to the Earth. You just may